We are on the page 16, section 1.8, logarithmic functions, log functions. We are going to review first, what are those log functions? How do they look like? Okay, so we will start from exponential function again. Exponential functions, right? And versus log function, because they are related to each other. Then we just saw a few application earlier, last section, and on exponential functions. And now we are going to see log functions and how we are going to apply them to the business world and social science world. So we know what our exponential functions are, right? So let's do it again. Why? Just do the basic. So let's take a look, and how should we graph them? So right? We did this earlier. So what we have was, you use t-table, y equal 2 to the x, right? You put a 0, 1, 2, negative 1, negative 2, 2 to the 0 power is 1, 2, right? 2 to the negative 1 power is what? Reciprocal. 2 to the negative 2 power is what? Reciprocal 1 over 2 squared, so it's 1/4. So when we graph it, n is what? Exponential function, right? So this is a 2 to the 0 is 1, and 2 to the 1 power is 2, 2 to the 2 power is 4, right? 2 to the negative power is what? Reciprocal half, and negative 2 would be 1/4. So its graph look like this, right? So that's our exponential function for the basic one, for the power of 2. Then we are going to reflect it over, let's see, if we reflect over the middle line, if we reflect, right, over y equals to x. What does that mean? That means we are going to switch x and y. If x and y are the same, x is x, right? 1, 1, reverse x and y, still 1, 1. 2, 2, reverse them, still 1, 1. Okay? We are going to reflect over. That means we are going to what? Switch x and y, right? That means you do y become here, x become there, right? So you switch them. So this one is what? 0, 1. So switch them will be what? 1, 0. This one is what? 2, 1, right? That's your exponential line. So that will be what? 2, oops, 1, 2, 1, 2. Switch them will be what? 2, 1. Then this one is what? 2, 4. Switch them will be what? 4, 2. Right? So this point is what? Negative 1 and half. Switch them will be what? half and negative 1. Half and negative 1. Right? We just want to see when we reflect over the y equal x this line, what happened to the behavior of exponential line? What will happen? See how it looks like. Then this point will be what? Last one, negative 2, 1/4. Reflect them, switch x and y, so it will be what? 1/4 and negative 2. So 1/4 and negative 2. 1/4 and, and negative 2. This is not right. This one would be what? Half and negative 1. Right? So, we are good. So when we graph this one, the line will look like this. So actually, it's like your paper. You fold over, then you fold over this line. The graph will look like this way. So, then let's look the log. What happened to the log function? Okay, so that's an exponential function with its reflection over that line when we switch x and y. So when we graph y equals log 2 of x, we say you cannot see the log directly, right? So you need to see it from exponential point of view. So in 154 algebra class, we did this way. We say you do the hook, right? This one equivalent to what? Base 2, right? Y is your power. 2 to the y power is what? Inside the x. Take a look. You have this one. 2 to the y equals x, and 2 to the x equals y. What happened? X, y switch position, right? So in here, we say when x, y switch position, you will have this graph. Then let's check on this. How we are going to graph this line, okay, for the log function. Same thing we are going to do is what? Do the t-table. So the way to do the t-table is, right? So that's your x, that's your y. So y is what? Log 2 of x. But we say we cannot see it, right? So we have to rewrite it as exponential equation. So then it means what? 2 to the y equals x. So instead of put x equals 0, 1, 2, negative 1, negative 2, to put the number and try to find the exponents, it's almost impossible for you and very difficult. But we can see if I put a y here, can I find the x? It's just your exponential equation. You just plug in the number. So what we would do is put the number here as 0, 1, 2, negative 1, negative 2. However, if we try to put this one, right? So if I put we can just try that for y, right? We put a 0, 1, 2, -1, -2. If we put it this way, what will happen? So y is that. So that means what? 2 to the 0 power is 1. That's your x. See? Then 2 to the 1 power is what? 2. 2 to the 2 power is what? 4. 2 to the -1 power is what? 1/2, right? So we go backwards. So 2 to the -2 power is 1/4. Okay, that's one way to look at it. Or if I use directly, we are going to review log value later. So if I use this directly, how will it look like? Right? Suppose y is log 2 of x. So I will write it this way. Okay? So I will write my y. If I put my x are those numbers, so I will do what? This is 1, right? X is 1. That means y is what? This guy, right? Log 2 of 1. You might have forgotten how to do the log 2 of 1. We are going to review a little bit later, but for the basic concept, means 2 to the some power is 1. What do you think that value is? That would be what? 2 to the 0 power is 1, right? Then for this one, y is this guy. If x is 2, that means what? You will plug in 2 for x. That means we are going to find the log 2. It means what? 2 to the what power? 2 to the what power is 2? 2 to the 1 power is 2, right? And for this one, log 2 base 2, x is 4, right? X is 4. Then what's the value? We are talking about is what? 2 to the what power is 4 is 2. So the y value is the number we get from the log. What happened to the half? So if x base 2 to the half, that means 2 to the what power? 2 to the what power is half? -1, right? 2 to the -1 power actually is half. And for this one, x is 1/4. What do we have? So 2 to the -2 power is 1/4. So when x are those values, that would be your y. If according to this, when we graph it, what do we have, right? So let's take a look. So when x is 1, y is 0. 1, 0. When x is 2, y is what? 1, 2, 1. When x is 4, y is what? 2, 4, 2, right? So x is half, y is what? -1. Half, x is half, y is 1. When x is quarter, y is what? -2. Quarter, -2. So the graph looks like this. So one is we do the log function, if you remember how to resolve your function, right? Or put it into the calculator to find the value, you will get such. Or we get reflection from the exponential function. The reflection is this one. So they end up same, right? So what we are talking about is log function is what? Inverse of exponential function. What does inverse mean? Means you switch your x and y. X and y, x become y, y become x. Is that right? So what we are saying is exponential functions and log functions are related to each other. Just because by looking at this, where is the log from, right? So if I have 2y equals x, then if I want to solve y by itself, we always solve y by itself, right? So y equals mx plus b, things like that. Y in terms of x. So when I have y in terms of x, so if I have 2y equals x, but I want to write y equals some x, how am I going to write it? So we invented long time ago and created this symbol for log to express what y is. Y is some kind of x. That's new symbol and new notation you learn in the algebra class. But they mean the same thing, right? So we explained what are log functions, what are exponential function, right? So we do the basic graph, let you understand how it looks like. The number, how do they relate to each other from x to y, okay? So that one is, this one is log function, right? And the earlier one is what? The exponential function. Okay, so at the same time, we are going to talk about domain and range. So in general, we write it this way. That's just for your reference for the base 2. What happens if I use what? In general term, instead use the 2 as a base. So my exponential function, then I have a base like b, just any number. So if I have y equals b to the x, y in terms of the x, right? So exponential function. So usually what do? Base, we don't use negative. We use base that because becomes 0, bigger than 0. Base is now 1. Okay? Your power, x is what? Can be any real numbers, right? We put in x here, then we graph it. X can be what? 1, 2, 3, 4, 0, and a negative number, or even fractions. We do have a power as fractions, right? So that's how we write a general term of the exponential function like this. Okay? And why we don't use base 1? Base as 1. If you have, say, So if y equals 1 to the x power, 1 to any power would be what? 1, right? So it doesn't matter what x are, so y always 1. So your line will, so this y, f of x, will look like this line. So no longer what? Exponential graph. So that's why we say b, so b cannot be 1. Okay? And let's take a look if we have, okay, we are going to talk about log function, right? That's in general, we write exponential function. Then for the log function, how do we write general term? So instead of using, we did this one log function, right? This log function is what? Y equals log base 2 of x. Reflect from that one, base 2. So instead of base 2, we are going to use general term base b. So we write it this way. Y equals what? Log function with base, oops, not 2, it's base what? B, then result is what? X. So we write log function general term this way. And same thing, base, right? Base bigger than 0, and base, we don't use 1 for the same reason. And what's your x? Here, the power position is any real number, right? Then y is a function in terms of x. Then we'll have to know what kind of x we are using. And what do you think? Because the x here is this graph, right? Take a look, what kind of x you can have. X is any point on the line for the x position, right? Things like that. Can x go over another side from the graph? It doesn't. So that means what? X is bigger than 0. So what does it tell you? X is all possible value for x is your domain, your territory. What kind of things you operate on? From point A to point B, from point X to point Y. So from point X, that means when you do the log, X has a restriction. It's what? Bigger than 0. So what does it tell you? This one is telling you inside the log has to be what? Has to be positive number, bigger than 0. Right? Okay. So, B is your base. Okay? So, B is your base. B bigger than 0, B greater than 1, as such. Let's take a look. It has also this situation. Let's just talk about B greater than 1. But usually we use positive. Sometimes we use negative for a reason. Okay, so let's just talk about b is greater than 1. So, what happened here for that line? Okay, so your graph look like this, right? From there. So what's your domain for the log? That means domain is all possible x value, right? It's what? 0 up to infinity, okay? Then your range is what? How far you can go up and down for the y. All possible value for y will be what? Can be going up, up, going down, down, down. So negative infinity to infinity. And it has certain property. Okay, so like this one, for this graph, it has what? It's limited by this line, vertical line for the graph. So this line we call it what? Vertical asymptote, right? To describe this line, we use what? X equals 0. In terms of for exponential function, it has what? Horizontal asymptote, which is y equals 0. They are opposite, okay? It means what? Vertical asymptote means what? When x approach to that number, and y either is negative infinity or positive infinity, okay? So for this case, when this line continue, right? Continue, right? So when the y approach to negative infinity, what happened? X approach to 0. I'm not going to test you on much on vertical asymptotes and horizontal asymptotes. Just give you a concept and the behavior of line. When we use it, it has a limitation. Okay? So, and we are going to talk about another one. It's something called natural log. So something called natural log function. It means what? Y equals ln of x. So you will see on your calculator, you will see this symbol ln. What does that mean? Okay, it means what? This one means y equals ln means what? Log base e of x. What is your e? We talked about last class, last section. E is what? Base e is 2.718,781 some number, right? A special number. On your calculator, and we only have two things. One is when you see the log and you see ln. Also you see ln, right? When you see the log, it doesn't have a base. But with our base can be what? Not 1, can be 2, 3, 4, all that. So your log base b, right? But on your calculator, if that is missing, it defaults to what? Base 10. And when you see ln natural log, it means what? Log with base e. Okay? So this one we call it what? Common log. Okay? Then this one, ln, we call it natural log. That's the two symbols we use calculator for. So then usually we will write it this way. We will have x there. then invisible 10. Then ln means what? Log base e of x. Let's review some properties of logs. So those are discussed in your previous algebra class, but we do it again. So let's do some observation, then we will relate back to the properties. Okay, so let's see. If you have a log 100 plus log 10, what is log 100? You don't have a base, means what? Base 10, right? So 10 to the what power is 102. Or you can type into the calculator log 100, you get a 2. Log 10 of 10, base 10, 10 to the what power is 10? It's 1. When we add it together, what should we have? Well, we'll have a 3, right? Is that same thing as log 1000? Right? Because it's a base 10, 10 to the third power is 1000. So where did you get that 1000? How can you get this 1000? From here. That will be from 100 because that's 110. How do you get that? From here? If you multiply them. Right? So first property is what? If you add the two log number, you multiply them inside. Okay? Then, why we are doing this? We are going to use the properties, log properties, to simplify them. So just like a fractions, you add the two fractions, you want to make one fraction, simplify the form. If you subtract fractions, you make one fraction. So we add the two logs, become one log, subtract them, one log. Then we simplify situation, so we can use one log to solve problems. Use the log skills to solve problems, but you need to have one log to be able to do that. Okay, so we are learning the skills, the technical skills, how to simplify the log. So if for subtract, just like this, if I have a log 1000, right, minus log 10. Log 1000 is what? 3. Then log 10 is what? 1. If 3 minus 1, I should get a 2. Right? Let's look. It's a log 100 is 2. Right? So, and how do we make this 100 happen? From original two number, one is what? 1000, one is 10. If we divide them, 1000 divided by 10 is 100. So the property is this way. If you subtract two logs with same base, then you can just simplify it by dividing the inside. Okay? Then let's take a look at another one. If you have a power base b, then you have another b to the power. What do you think? Oh, I missed one. Okay, so let's do this one first. And if I have this one, power property, I missed one. So if I have n times log base b to the n. Okay, so what happened is I have something outside the log, but we say we want to simplify, just become one log, everything is inside with a base. So let's take a look at this. So for this one, and let's see some examples. So if I have 3 times log, we just use base 10, right? 10. 3 times some kind of log, but I don't want anything outside of the log. I want to have a single log, everything is inside to help me to solve problem later. Okay, so log 10 base 10 is what? 1. 3 times 1, I should get a 3, right? So to be able to get 3, what kind of single log I have to have? So for base 10, is that 1,000? Right? So to get a 3, and from here, we wanted to have a single log. But from those numbers, 3 and 10, how can I get inside become 1,000? It's that same thing as what? 10 to the third power, right? 10 to the third power is that. So from 3 and 10, if you move 3 outside to the power, you actually get a correct number. So to simplify this one, that means you will get base B for the what? Inside whatever, then you will move the power inside, then you will have same value. So we make a single log this way, right? Okay, then let's take a look with your some example first for those 3 properties we talk about. All right, those product property, quotient property, those like power properties. See, let's see some examples. Now we are on the page 17. So let's do those properties first. Okay, so get familiar with. And let's see, if I have this one, we say logs are opposite reverse of exponential things, right? So they are interchangeable. So I have what? Log things here. They are interchangeable with exponential things. So how do we change it? We say you hook, right? Do the hooking, and that will rewrite the log as what? 3/4 to the 81. Is that right? 3 to the 4th power. 4 times 81. So we get familiar with the log interchangeable with exponential things first. If right now I give you the answer, later on we will not give you the answer, expect you find the value, right? If we do this, so it means what? Same thing as what? 2 to the -3 power, you do the hooking, 2 to the -3 power is 1/8. Is that so? What does -3 mean? It means what? Reciprocal, 1 to the 2/3 power. That's 1/8. Okay? So we are reviewing the basic concepts of the log interchangeable with the exponential things. Okay, and vice versa. If I have 5 squared, is that 5 squared equals -5? 5 squared equals 25, right? So if I change it to log style, how would it look like? That would be what? Log, what is your base? 5, base on the bottom, right? Then you want to do the hooking, right? Hooking, you end up this way. So 5 to the what power? Square, you write here, you put it inside. That's what it means. So if I don't give you this, I say log base 5 of 25, what's the value? It should be the 2. That's the value of the power position. If you look this 4 to the negative 2. Is that 1/16? Right? Reciprocal 1/4 squared. If you write it in log style, that would be what? Log, what's your base? The bottom. Base of the exponential things, base 4. Then, which one you put inside, which one you put outside? You know, you hook 4 hook to the power to the number. So that's your negative 2, that's your 16. That's how you write. Okay? So, this is just a transformation. You translate between the log and the exponents. When you cannot see the log number, you use exponents. Right? So, and we are going to use those properties to solve problems, okay? And we already did product, quotient, and this. So we haven't talked about those things. All right, and just try to see which one we wanted to talk first. Okay, read this. All right, so let's see. We are on the page 17, right? Part D, and we try to connect between log and exponential thing. So we use the base 10. 10 to the 0 power is 1. 10 to the 1 power is 10, right? 10 to the second power is 100. 10 to the third power is 1000. 10 to the negative 1 is reciprocal 1/10. 10 to the second power is 100. 10 to the negative 3 power is what? 1000. If I write it in the decimal form, 1/10, right? 100, 1000, right? So, if we translate this to the log, right? So you have what? Log 10 of what? 0.001. Is that right? So you hook. What kind of power you use with base 10, you will have the value 0.001, and it's negative 3. Type in your calculator without the 10, base 10, because that's common log. Then type in this value, see you can get a negative 3, right? So if I have a log 0.01, type in your calculator, what should you have? Negative 2. Is that right? Because 10 to the negative 2 power is 0.01. So for this one, log 0.1, 10 to the what power? What power become 0.1? That's that one. So type in calculator, log 1, right? That's your value. 10 to the what power? You hook it, you should get 0. If you type in calculator, log 10, right? What do you have? 1. If you type in calculator, log 100, what you get? Power position 2. If you type in log 1000, what do you think? Power 3. Also, try to type in log, those are not on your paper. Okay, C, what do you have? -1. Try it on the calculator. You should have some kind of things called error or domain error, right? Why? Why the calculator cannot do it? We say inside the log has to be what? A positive number. Cannot be negative number. That's why. Right? So, then look at the right hand side. Okay. Then let's talk about those properties. Then we will use the calculators with this property to do to find the value. You can either do it by hand or using calculator, same way. Okay, but with different base. Let's take a look at this one. What do you think? You need to hook b to the some power become b to the m power. B to the some power is b to the m power. What do you think? That answer should be, of course, m. B to the m power is that b to the m power. Because you switch what? You hook bm equals what? Bm. Is that right? Bm equals Bm. So you hook Bm to the Bm power. That means if you do the log base b, you have b, same thing, to the same power, then you should get what? The power value. Right? Then if you look at this one, actually simplified is what? This one is like you cancel the base, right? You got that guy, so you cancel that. And this one is like you cancel this. Okay, it's like you cancel this, you get an M. The reason is this way. Right? We say, if I rewrite, it's not that obvious, so you can take a look. If I rewrite it, we say b to the y power is what? X, right? I can rewrite this as a log. I would write what? Log base b, you hook to here, right? So which one you put inside? The result, put it inside y. So you do hook. That's how we change, do the hook, and you get it inside. That's how we change the exponents to log form, right? So if I write it this way, how would I write? B, this one is exponent form. So this one is exponent form. Then, like your B is B. Log Bm is your Y. This way. So if I rewrite this one, I will write, this is exponential form. I'm going to rewrite log. If I rewrite the log, I will write what? My log base is b, right? My inside, so I hook inside, right? Inside is m. Then my hook is this one. Take a look. This is my log. If I rewrite this log, I will do b, hook this one up to become m. So my base is b. I hook this. My base is b, I hook this. Then I get inside m, right? At the same time, take a look. Okay? Is log bm equal log bm? Of course. Then I can rewrite it. This is kind of confusing for you. All right? But we're not going to test you much on that. But you practice on the homework. They mean the same thing. That means if I have a base log and log bm, I can kind of cancel out that and become the value of m. That's the reason behind those things. Okay? It's a little bit abstract for you, but take time to think about it. It might be okay. Right? So, let's take a look. Look this first. Example. If I have a log b to the 1, what do you think the result is? B to the what power any base? To the what power is 1? That's 0. Right? And log b is what? B to the what power? It's b 1. Right? So if you look at this one, b to the what power? 1 power. So your result is the power position, that's 1. If I have log b to the x power, what do you think? Like here, it's kind of neutral out itself. Becomes what? X. If I have b log bx, it's like here, it's x. Okay? We are still on page 17. And for natural log 1 equals, so natural log means what? Log base e of 1. What do you think? E to the what power is 1. Anything to the 0 power is 1. And natural log e, that would be what? Log base e. What do you think? E to the what power is e? So it's like here, it's a power of 1 actually, so it's 1. And natural log e to the x is natural log base e, right? Natural log e to the x power. Then you use this property, then you should get x. E to the x power is e to the x. E to the natural log x, that would be e to the log base e of x. So you will have x. Right? Then look the 5 portion, natural log e to the 7. So that would be log base e7. Oops, that should be 7. And natural log e to the 3x. Natural log actually is log base e. So use this property, right? So you will have 3x. Natural log cube root of e squared. So we can change the square root and to the power style. So it's what? Top one is the power, bottom one is the root. So we will have 2/3. And e to the natural log 5, right? So it's like this one. So neutralize, then it's 5. Then let's look another property. So for this one, we have log base a to the n. So your calculator only can calculate what? Base log. Log, you don't see anything, means what? Base 10. Right? And or natural log means what? Base E. So if you have the number log, say 2 to the 2, then you can think about it. It's 1, right? You hook it. If log 2 to the 4 is what? 2, right? What happens if log base 2 and 5? What kind of value is that? How you are going to find it? We are going to use base change formula. It's same thing as log n over log a or natural log n over 8. So this way you do what? Punch in the calculator log 5 or base and log 2. Same thing as you do, you use a natural log and natural log 2 to do that. Okay, so let's look some more examples for the numbers. On your right hand side portion of it, we haven't talked about. Take a look at those. Okay, so on your right hand side, you have this log 5, 125. So what do you think? 5 to the what power is 125? Third power, right? Times 3 times. Or you can punch into the calculator by doing what? You can do log, right? Or you can do this way, log what? 125 by using this base change formula, log 5. Then try that and you will find out it's 3. How about log 9, 3? 9 to the what power is 3. You hook it. It's not that obvious. So what you can do, you can do it this way. Think about it as you try to find the value. For the things we don't know, what can we do? We say, okay, that's my x. Then, how am I going to find the x? Right? So, you do the hook. So, what do you have? 9 to the x equals what? 3. So, what kind of equations we have? Exponential equation. How do we solve exponential equation? We change to the same base. So you can change this through to the square to the x equals 3, right? And so you have what? 3 to the 2x equals 3, which is power of 1, same base. So what do we have? 2x equals 1, then x is what? Half. So what do we have? And to check, right? Is that 9 to the half power is 3? Yes. 9 square root of 9, it is 3. That's how we find the value of the log, or we can do it is by using the x, then change it to what? Exponential equation. Take a look at this. Log a, base a of 2. What kind of a value would be that? Right? So what can we do? So you say, okay, this one is called x. Then I transform my log function becomes exponential function. So a to the x power is 2. Then I change it to what? Same base, right? I use same base. A is what? 2 to the third power to the x is 2. So what do I have? Power on power, you multiply your power, right? So we have what? 3x equals 1. So what is your x? X would be 1/3. Is that right? A to the 1/3 power is 2. Or how about we use calculator to find it? So how can we do that? So for this one, we can use base change formula. Use log what? The inside first, right? The inside on the top over what? Log 8. So you divide them, you will find out your value is like 3, 3, 3, 3, all that. It's similar to the 1/3. You can do that. Okay? And same thing as this one, you can use calculator, log 3, try it, divided by log 9, then you actually get 0.5, which is half. That's how you use base change formula if the base is not 10 or e. You need to use this to do that. And that's how you can do it, either by hand or use calculator. Then for this one, okay, so for natural log 8.34, no way you can do it by hand. So what do we need to do? We need to use calculator, right? So this one means what? Log base e, a to the 3/4, right? Then what do? We can use, oh no, you don't do that. Because natural log is what? Base e. Actually, you have a calculator, has this thing, right? It's ready for you. So all you have to do, just punch in to the 8.34, then you get a number. That will be your answer for this. That's a review how to solve the exponential equation. And we need these skills for our apps, okay? Either in the financial world or social science. So 2 to the x power, that's on your page 18. What do you think? What's your x? So for exponential equation, we will use the same base if we can. So that would be 2 to the x power 8 would be what? It's this one is 2 to the third, right? Then reciprocal 2 to the -3. So what's your x? -3. That's how we solve exponential equation. We can use the same base. However, what happened, like this one? 1 is 2, 1 is 7. We cannot make the base the same. Then we need to borrow the new skill we learned from the log. So you rewrite this one to the log. How do you rewrite it? Log base what? The bottom one, base 2. Then what's inside, what's outside? So you hook the power, become the result. So you put the result inside, and outside is the hook, the power. Then what do? We use what? The calculator, right? Change this one, use what? Base change formula, right? So that would be your x. And your x is about 2.80735. Use as many numbers, decimal point as you can for the accuracy. You only simplify it, round it at the end. So to keep the accuracy. But if you use the cell phone, you will have too many decimals. Just use a few and you'll be okay for our purpose. So take a look if you have this one. How we are going to handle. So that's that exponential things. You have some other things outside. So the way we can change the exponential equation and function to the log, it's just a simple exponential thing. So you transform it. So this one, besides the exponential thing, you also have extra thing. So you want to remove that, get rid of it. So you make it simple, right? Then what do? Now we can change this, become the log. So we will do what? Log base what? E, which inside, which outside. You hook the power, right? Become this, that's the result. And log E is the same thing as your natural log on your calculator, right? Then you find this number. Then to get the t, then you divide by this. So your t is about 5, 4. That's how we find the value of t. Then we are going to use this skill to do some our apps problem. Let's see. We are on page 18. And try some apps. See how it works for the exponential equations and log equations. Then see how we are going to use those skills to find the answer for us. Take a look. First one, for financial application, finding doubling time. Let's see. The problem, it says, a sum is invested at 12% interest, compound quarterly. How soon will it double in value? So it says what? We try to find out how soon it will double in value, right? That means I have $1,000. If I get a 12% interest invest, right? Then how long it will take if the 12% remains? How long it will? I will get $2,000. If I have million, how long it will be 2 million, right? So for the future value. So what's the formula for the future value? If it's compound quarterly, right? We have this. Future value equals what? Your principal times 1 plus your rate, annual rate, divided by how many times per year, times what? MT. Right? So that's your future value. And what's your principal? We are going to double, right? So we just use the regular principal. We don't need to use 1,000 or 2,000. So then rate is what? 0.1212%. M is what? 4 times per year, right? We are going to find the time and enable us to double it. And look at this equation. What kind of equations we have? We are going to find the t, right? How many years? Is the money, future value, is the function of the t. So we have what? variable is on exponential position. So we have exponential equation, right? So we say FV, we want to double, become what? 2P. Double, it was P, right? So 1 plus your R is 0.12. M is what? 4, then 4T. So we have an exponential equation. How we are going to solve it? So divided by P, so we have this point, that would be 1.03, right, for T. Does this look better? We have an exponential equation. How we are going to solve exponential equation? We just practiced. We have two ways. One is make the base the same. Can we do that? Not for this case. If we cannot, what we need to do? We will transform it and use the skill on log to resolve exponential equation. So we will rewrite it as a log, right? Log base what? That's your base, 1.03. Then what's inside? What's outside? You hook to your power. You hook to your power, become the result. That's how you write. Then how we are going to find the value of log base 1.03 of 2. So you use base change formula, log 2 divided by what? Log 1.03. Make sure you use calculator practice. And for this, right? Get a value. Then what is your T? Then you divide it by 4, divided by 4, right? So your T is log 2 over log 1.303. Make sure you do that. So you can do your homework, all that. So it's about 5.9 years. So this one is compound quarterly. Look, second one, finding tripling time with continuous compounding. So what's the continuous compounding formula? That's the one we are going to use. Look at the problem. It says a sum is invested at 15% interest, compounded continuously. How soon will it triple? Right? So let's take a look. 15% interest annually, that's super high, right? We wish. So what's the formula for compound continuously for the future value? That would be what? Principal times e to the RT power. So principal, we are going to triple. So we just put the principal P. Okay, you can use 1,000. Triple would be 3,000, right? So, or you can just use P. R is what? 0.15. T is the years we are going to find. So, future value is what? 3 times that much. So, that P, E to the what? R is 0.15 to the T. So, we can cancel out the P divided by P, right? So what do we have? 3 equals e to the 15p. What kind of equations is this? Exponential equation. How can we solve exponential equation with different base? We will change it to a log, right? So you have what? Log base e, which inside, which outside. E to the power for the result. That's how we do. Log E actually is what? Natural log 3 equals 0.15t. How do we find our t? Divided by 0.15, right? So your t would be what? Natural log 3, okay, divided by 0.15. Make sure you can use calculator to calculate those numbers. If you do have a problem, call me. Then I can go over with you and on the phone. So it's equivalent close to 7.3 years. That means if you get a 15% of interest, then in 7.3 years, you can triple your money, right? That's a lot. If you have a 1 million and 7 some years, you can have 3 millions. That's very huge. We just talked about the apps on financial application, right? For the exponential growth. Then let's look some applications for exponential decay in the social science field and how we can actually apply it. Okay, so let's look your page 19. We are going to see something you actually use in the medical field. Look at number 3 and calculating drug dosage. It says the amount of drug that remains in a person's bloodstream decreases exponentially with time. If the initial concentration is C milligram per milliliter of blood, the concentration T hours later will be with this formula. Let's see what does this one mean, okay? Where the absorption constant K measures how rapidly the drug is absorbed. So let's see what does this function mean. This C and little c is different, okay? So this one is what? Concentration depending on the time, total concentration left. This C is what? Initial situation, how much you put in, penicillin say, okay? Then your power is what? We use this style, remember, we have exponential growth continuously, right? For exponential growth continuously, the formula is what? Future value equals e to the, oh yeah, you have a principal, e to the RT, right? R is positive, so it's growth. If the power is negative, it's what? Decay. So it's a similar style, right? Continuously, you use the base E, okay? So let's see the example, then see what does it mean. It says the absorption constant for penicillin is K is what? 0.11%. And the minimum effective concentration is 2 milligrams. If the original concentration is 5 milligrams, find out when another dose shall be administered in order to maintain an effective concentration. What are they talking about? So if we put a 5 milligram dosage to a patient, right? Then it would decay. You know, the body will be absorbed by the rate of what? 0.11%. That means it would deplete and being absorbed 0.11% per hour, per minute. Let's take a look. Did they say it? They didn't say it. Actually, it's per hour. Okay? So then depleted until down to 2 milligram. Is that milligram? Yes. In the body, then become what? Not effective. So at the time, we will inject another dosage to help the patients. That's what I mean. So the question was what? What was the question? Original question? It says, okay, if the original concentration is 5 milligram, so initial injection 5 milligram dosage to the patient, then we want to find out, okay, when we should do another dose, then to keep the medicine effective. That means the left in the body should be 2. So after certain hour. So that's your variable. So the decay rate is 0.11. Then what is your C? That will be your initial dosage. That will be 5 milligram, right? Then after certain hour, it depleted, become the leftover dosage in the body, which is 2. So we want to find out when it will start from 5 become 2 by using this formula, right? So what kind of equations we have? Variable is in your exponential position. So you have exponential equation. Then to solve exponential equation, what do? We have to get this exponential thing by itself. So we have to get rid of 5. So divided by 5. So we have this one. Is that right? Okay, how do we solve exponential equations? We cannot make the base the same, so we change it to what? Log. Right? So log base E, what's inside, what's outside your hook, the outside of the exponent to be the inside. So log E is what? Natural log 0.4, right? Then how do you find your T? You divide by this. Then you use calculator, find it, okay? So your T would be what? About 8.3 hours. So what it's saying is after 8.3 hours, the 5 milligram dosage will decay to 2 milligram dosage. Then by then, and they have to put in and to help the patient, right? So to keep it effective in the patient's body. That's how we use the, so when you look at the label of the medicine, if in the medical field, they say, oh, after 8 hours for this penicillin, you need to, each time you inject the patient 5 milligram. Then after 8 hours, 8 point some hours, you need to inject another one. That's the background information. That's how it works. They find out after 2 milligram, and the patient will not be so effective to treat their situation. So if you do the research, right, then you will understand that's how they do. Let's take a look at another example for the carbon dating. So we use this quite a bit in a science field like anthropology or research. Like we find a dead body over ice glacier somewhere, then we want to find out, by carbon dating, how old is the body is, right? So let's see the example we have here. It says the Dead Sea Scrolls discovered in a cave near the Dead Sea in what was then Jordan. are among the earliest documents of Western civilizations. Estimate the age of the Dead Sea Scrolls if the animal skins on which some were written contains 78% of their original carbon-14. What are they talking about? They find something there, animal skins. Then they did chemical testing, however they do, right, in a chemistry field. Then, or biology. Then they find out it's 78% remaining of the carbon-14. So it's the same thing. When used like exponential growth, we are doing exponential decay. Only the difference is the rate is negative, right? So it's like, okay, this is the remaining, right? Then the future one, this is the beginning, Q of 0, right? Q sub 0 at the beginning. Then you follow this because it's continuous. This is a continuous growth, and decay, like carbon dating, it will be continuous. So we use this formula, then decay rate times time, right? So we can do what? It's a remaining, right? Would be what? The original one, whatever it was, then to the E to the KT. What's our K? So K is for carbon-14, that's the decay rate. Then you can find this information online everywhere, right? It will be given to you. So then it says originally is quantity Q of 0, then remaining when they test is 78%. That means what? 0.78 Q of 0, right? That's how you write your equation. How do we solve the equation, exponential equation? We have to get this exponential things by itself. Get rid of Q0. So we divide by Q initial condition. So we have 0.78 equals what? E to the some exponential thing. How do we solve this? For exponential equation, cannot change the base the same. Then we will change it to the log, right? So your log, what's your base here? E. Then what's inside, what's outside? You hook the power here. Then the result is here. Then log E actually is what? Natural log, right? Which is on your calculator. Then you use that and to find the value. Then you divide it by what? Negative 0.00012, negative 0.00012. So your T would be 271 years. That means the things they found out on the animal skin, which is 78% of its original carbon-14. That means the thing has been decayed for how long? 20-some hundred years, around 2,000 years. Now let's look at the page 20. Number 5, predicting the spread of information. Let's see the example. This one we might use it for weather report or mass media industry. Okay? Or it might happen for our coronavirus, right? So let's see how it works out. And this example, how can we apply to the similar situation? it says a storm warning is broadcast, and the proportion of people who hear the bulletin within T hours of its first broadcast is what? This formula. Population heard according to the time, or not the population, it's percentage here, okay? So how many percentage of people heard the report? Then spread out the report is by this formula. This is a percentage according to the time, okay? So that's your percentage portion. Just like a virus and percentage portion, right? Like a 2% suddenly become 20%, 50% of the population, it becomes serious. And for this equation, how can we get those equations? We need to do the stats, and they will generally then collect the data according to the time, what will happen, then they find the formula for it. Okay, but for your class, for the purpose, we will give you the equation. Okay, so say percent portion, the spread of the information is by this formula. So during, say, hour 1, what's the percentage? Hour 2, what's the percentage of portion? And population will hear the news, right? So if it's given to you and you say, oh, when the 75% of population portion of people change the 75% become decimal, then we hear the news by doing that. And according to your time. What kind of equation we have? Exponential equation. How do we solve it? Get this exponential thing by itself first, right? So we have negative 0.25 equals this. Then we still have a negative extra, so we divide it by negative 1, so we have this. Now we have simple exponential equation. Then how do we solve it? Not the same base, so we will rewrite it with what? Log. Log base e. Then with the hook the exponent to the result is this way. Then log e means what? Natural log, right? Natural log. 0.25 would be this one, right? Then you use calculator, find the value, then divide it by 0.30, right? So your T is about 4.6 hours. If according to this formula, and after 4 or 5 hours, and 75% of people will have heard the storm warning. That's pretty quick. Then for the another application on the bottom, number 6, for the chemistry. If you are interested, you can read it. All the details are written on the paper. You can take a look.